Okay, so I gave you these three theorems a couple days ago. We're going to talk about these three today. We have a grand total of 4 theorems that we're interested in. The first one I gave you was what?
IVT.
IVT. This one is MVT. Then we have Rolle's. These two are related. They go together. Okay? And then EVT, that was so difficult. Wink, wink. These are all pretty easy. These two in the middle, at least, you have to think about for half a second. Let's do Rolle's first. Rolle's may be a little easier to understand. Rolle's theorem says this. On a continuous function, on the closed interval AB, if the y coordinates at A and B are the same, if the y coordinates at A and B are the same, so can you see those are the same y coordinates? They happen to be, in this case, have to be what?
0.
0. Okay? It doesn't matter 0 or not, as long as they're the same. If f of A,
The x coordinates have to be opposites.
f of A, they can be any numbers. The x coordinates can be any numbers. All that matters is that
They're zeros.
when they're the same. They don't have to be zeros. They're the
Okay.
same. It could be any number. If that was 10 right there, if f of A is 10 and f of B is 10, doesn't matter. As long as they're the same y coordinates. You okay with that? If they're the same y coordinates, then Rolle's guarantees somewhere between A and B,
The slope is zero.
there is a C. There is a C with a slope of 0. So f prime of C has to equal 0. That's what it guarantees. We're given A and B on some function with the same y coordinate. Somewhere between there's a C where the f prime of C is 0.
Somewhere in there there's no slope.
So it could be. So that's either gonna. Is that always gonna be either a maximum or a minimum?
Yeah.
Yes.
We're going to have to say no.
What?
Yes.
No, because
Because the only way I think that it could still be zero and it not be is if it was.
It could be like
if it was
a,
linear and if it was the same point.
So we're going to say yes, and EVT is going to clarify why that's a yes when we get there. All right, give me 1 second.
okay.
But is everybody okay with that? That makes sense to you?
C. I'm
If
okay.
you think about the max or min thing, if you think about that idea, then yes, it's a max or min. As long as you have 2 points around that max or min with the same y coordinate, doesn't matter where they're at. Then Rolle's theorem guarantees somewhere you have a f prime of 0. So that's Rolle's. Mean value theorem is the same theorem, generalized. So now they don't have to have the same y coordinate. What Rolle's theorem tells you is if you apply the average slope formula, so f of b minus f of a over b minus a, your algebra 1 slope formula for the endpoints. Whatever that number is, somewhere in between is an f of c, is an f prime of c that equals
Has the
that
same slope.
same slope. This is the average slope form. This is algebra 1 slope. That's what we just did in that table a while ago, right? I showed you that, in that table it said the f prime was equal to 2. And I said if you take the points on either side of it and apply the algebra slope formula, we got a slope of 2 right there. That was the same example. That was an example of the mean value theorem right there. So you find the slope through A and B. Somewhere in between is an f prime of that same number.
kind of given.
These are all given ideas. It's just these are theorems backing up what you understand to be true just from experience. Okay? So that's mean value theorem. Find the slope through A and B, whatever that number is. Let's just pretend this is 2/3. Okay? Pretend this is 2/3. Somewhere in between here is a C that has a slope of 2/3 as well. A calculus slope of 2/3, an instantaneous slope of 2/3.
It has a slope for 2/3, like the point is 2/3.
No, it has a slope of 2/3. The instantaneous slope at this point is 2/3.
And so what if you had the same thing again, and it wasn't like an arch? If we had like the graph that we drew where it made like an S curve, and you had 2 points on the S curve.
So I'm gonna draw an S curve like this, okay? And I'm gonna pick any 2 points. I'm gonna pick that point and that point.
Okay, and I understand that one, but what if it was like where we had earlier how there was a point of inflection and it just went up like that? Does that make sense? So there isn't like, there wouldn't be any maximums or minimums.
Like that,
Right.
okay?
And you pick
So
a
pick any
point.
2 points,
So like up at the top and up at the bottom?
right there,
Yes.
down here.
Yes.
Notice if I put one down here, it's also gonna cross here.
Okay. Oh, and so that point right there would have.
So this point right there will have the same slope, somewhere between those two.
Oh,
And
okay.
if I extend it, guess what? Between here and here,
That's point right there.
we also have another point with the same
Gotcha.
slope. Okay?
Crazy.
Now EVT, coming back to your thing about, does it have to be max or min? If I have any function, continuous, it's guaranteed to have both a min and a max. It's guaranteed to have both a min and a max.
Well, if it's,
So here's a simple one.
like, if it's a,
We'll just draw that one. That's a simple one, right? Min and max, guaranteed to have those.
but if
We're
it's
going from-
linear, it won't, right?
We're going from A to B. Hold on a second. I'm getting there. Okay. We're going from A to B, min and max, right? We're going from A to B. Not linear, but can you see it's got a endpoint on it? It's a min and max. A to B. Min and max. Now here's the ones that we're going to have to more than one min or max. Horizontal asymptotes. So A and B. The horizontal line, is that a min?
Is a max and the max.
Is that a min?
The min is a max.
Is that a min? Is it the smallest number?
It's both.
Is it a max? Is it the biggest number? Is that a min?
Holy crap.
Is that a min?
This shouldn't exist.
Is that a min?
What
Literally
about
every
if
point.
it was like
Literally every point.
the interval and then like, you know?
So come draw what you need. I don't know, so come draw what you need.
You know. Can you read my mind?
Like, is it upside down? So that's the interval. What if it was like that? You know?
So,
There'd be
talking about
no
asymptotes?
min.
so if you look at all three definitions right here, all three definitions require that you're on a closed interval. You have endpoints. So if I look at your example right here, I am forced to have an endpoint here at A
So what if those endpoints were the same?
and here at B.
There'd be no.
Both mins.
That'd be mids.
So
They're still mins.
you mean like
I
that?
thought there was no.
Hold on.
I mean, multiple mins.
You mean like this? So AB, right, it's a vertical line?
No. I mean, like if it was the upside down U, like what I just drew, but without the arrows with endpoints.
So, okay, so there we go, right there. So both of those are mins.
So you can have min. Oh.
Yes. It's guaranteed.
Guaranteed to have at least one min, but you could have multiple mins.
And then you get one that.
Oh.
In this case, you'd have one
The other
max.
one
I
on the left
thought you
again. That you just drew.
This is not a function,
Okay. Yeah. I was like,
right? This is an
That's the
asymptote.
definition of a function. X does not repeat.
Okay? All right. I'm gonna smack you guys after you're done smacking yourself.
let's snack out like.
All right, so let's get started here.
So it's Germex. Let's roll into these theorems, boys.